Welcome back again. This is the third video in our Powering Addy series. In this video, we'll be installing our Victron system into our 4170 Addy. So Chris and his team is going to do the install. Matt was out there with him a lot too, pretty much slowing him down and asking him questions. So you'll get some of that. And you'll get to see, how people install solar in very cold weather in North Carolina because it snowed twice.
Above and beyond, to say the least. So it goes without saying, but the link to EcoEthic Solar is in the description. If you're interested in having them help you out with your rig, they certainly get a recommendation from us, and we'll encourage you to reach out to them. Other than that, we'd love to have you subscribe to the channel, and if you're interested in technical and in-depth videos like this, please give us a like. And
if you have a question, put it in the comments below. And if we can't answer it, we'll ask Chris to answer it for us.
For sure. He's very helpful and very responsive. So this video certainly isn't going to cover all of the steps that were done. As Ange said, I was slowing them down with videoing, so I tried to be there only every once in a while. So we certainly have missed some steps. So any questions or things like that, please put them in the comments, and we'll try and get you an answer. Without any further delay, enjoy the video, and we'll see you in the next one.
Take me to the place where I come from, the only place where I really belong. Take me 'cause this voyage seems so long. Back to you. Ooh.
Over here. So far we've removed all the factory Victron components, the factory inverter, the Orion, and the factory charge controller and servo. In this area we're going to put diamond plate and basically wall this off.
Okay.
And then you're going to have diamond plate and everything, and that's what we're going to mount all the equipment on. Let's see. Down here we've added a 2-inch conduit from this point all the way to the interior bay near the transfer switch, and that will allow us to send and receive power from the transfer switch area. Okay. That way we're going to get the wire in, and then we can get it up into the bay above us through this chase here.
Right. And
then batteries are going to live in this area. I think we're going to have roughly 600 amp hours at 24 volts. So that'll be a significant amount of battery.
Right.
I think that's about it. So far we've gotten the AC wires pulled, the new conduit added in, welded a little bit of support onto this bay, just so we're not sitting on just pure sheet metal.
Right.
I like having a little bit of rigid support in here,
right,
especially since we're going to be adding, a couple 100 pounds of batteries to
right.
this bay.
Right, there we go. Now I got it. Yeah, and you've...
And then we'll add a little bit extra paint and stuff to that so the welds don't rust or anything over time.
Right.
Right.
Cool.
Yeah.
Okay, so inside.
I was just looking at it.
Angela's going to be interested in seeing the pictures, so...
Cool.
Okay, so heat pads underneath the batteries to replace...
Yeah. This had internal heating.
Right.
I'm not a fan of internal heating for more than one battery. Once you have multiple groups of batteries, you don't want internal heaters, because if the battery's at two different temperatures, one internal heater could activate and discharge the battery slightly and bring the whole group out of balance.
Got it.
So we're just adding heating pads underneath these batteries that we're adding in, and that will allow them to heat as one.
Great.
So,
okay.
Yep.
Smart Battery Protect here.
So a Smart Battery Protect is a smart relay that will connect or disconnect all the house DC loads.
Okay.
So the idea with this is, let's say a hypothetical situation that we've gotten to a low battery condition, and the inverters have already shut down because they're at a low voltage. we want the DC side to shut off as well.
Okay.
At around the same time. And this will shut off all the DC lights and things in the house,
Right.
so you don't continue discharging the batteries to a point of no return.
Right.
Because you can get those batteries down so low to where you have to wake them back up. We want all this system to shut off before the BMS in the battery shuts off.
Right. And that way then when you start getting solar light again, it can charge and bring things
Correct.
back up, and then
Yes.
the inverter chargers will
And in
do
a
their
lot
thing.
of cases, the solar will wake the batteries back up if it got into that point, but we don't want the batteries to ever get to that point, if that makes sense.
Absolutely.
And that's what this device is for.
Right. Okay. So here, these are the Orions. So I'm guessing these are the 24 to 12 volt
Step-down converters.
Step downs to the house batteries.
That's correct.
Right.
And each one of these will do 70 amps at 12 volts, so that gives you 140 amps at 12 volts to supply for your DC loads,
Okay.
which in some cases is not enough because you have an onboard generator.
Right.
So what we're doing with this is we're going to regulate these guys to around 13.4,
Okay.
which is a safe voltage for all DC systems in your vehicle. But then the outputs of these are going to a buffer battery and then on to your house systems. The reason we put the buffer battery in is so if you have any large surge loads that these can't supply the surge for, the battery can give you that extra oomph, an extra 50 to 100 amps of surge.
Like the inrush on your jacks or
the generator.
or the generator or something like that.
The starting circuit on the generator. So let's say we've gotten to a perfect storm and our state of charge is very low because now we need to start the generator.
Right.
Well, if we didn't have the buffer battery in and the state of charge is very low on the batteries,
Right.
these guys are directly related to how much is coming in.
Right.
So if that's the case, then the output can only give you so many amps at that point, especially if the battery's a low state of charge. They can't dump the amount of current you would need. That's where the buffer battery really comes in and shines.
Okay. And then we got the MPPTs, right? A couple of those for the various units. This one we've talked about. This one is going to be the interface between the truck
Correct.
and the DC side of this.
Yes, and we're going to do things a little bit differently on your truck. If I'm not mistaken, your truck has the built-in 2,000 watt system. So in the Fords that have the 2,000 watt inverter system, they have a secondary alternator and a 24 volt system that is powering that inverter. We're going to take a feed directly off of the two small AGM batteries that are under your back seat, and we're going to directly feed 24 volts into this device, which will allow us to use the full 1,400 watt capacity of this device because the voltage is higher. The system is nominal 24 volts on our side as well. So all we have to do is rectify the unregulated voltage coming off of the 24 volt alternator and steady it out at say 28 to be able to charge our batteries here. And these have a 3-stage charger built into them.
Okay. So what that means is, in addition to me having solar, the generator, and now I have the ability of charging my house off of the car if I needed it, right? So I have three different input paths. If any one of those input paths break before it gets to the system, then I've got triple redundancy on my charge input for keeping up with power draw if I need it.
Plus all you have to do at any point, even if this wasn't working, is plug into shore power.
Right.
And this will output 24 volt DC to your system as well.
Right.
So you have redundant charging sources.
If it's worth doing, it's worth overdoing.
Absolutely.
Okay, thank you for that.
Mopica universal sensors. So you can do any kind of liquid commodities, whether it's water, gray water. If you're doing gray or fresh, you would use this collar.
Okay.
But we're not, since we're doing propane, it's got neodymium magnets.
Okay.
So all we have to do on this, hold for 10 seconds. All right, so the sensor should be activated. And then we can go into the Mopica app and make sure. And then we'll go ahead and name it now.
Okay.
With these types of sensors, you want to name them. Install it, name it. Move on. Install it, name it. Because if you don't, you'll have to go off of that RFID number that's like 30 digits long.
Okay.
So I just do them one at a time and name them.
Okay.
Ask me how I know.
Sounds like the voice of experience. Okay, so you measured the state of charge on the batteries, and it came out to 26.6.
I measured the voltage, not the state of charge.
You measured the voltage.
Yeah, 26.67.
And so now you've set your bench supply to that, and now you're pre-charging, as you said, the rails, which eventually is actually going to go to here.
Correct. It'll pre-charge the caps in the inverters. It'll pre-charge all the caps in these.
Okay.
Which will prevent sparking
when you hook the batteries
I turn
up.
this on, because there will be no potential, because we'll be at the exact same voltage as the battery.
Right.
So that's the concept there. And then if we have a short, this will tell us we have a short before we do anything else.
Okay.
So let me put that guy on. So if we had a short, what you would see, this is just would immediately spike on its amperage, its voltage would drop to nothing.
Right.
But we don't have a short because we're at 0.3 amps. The capacitors and the inverters are charging up now. Looks like everything's coming online. And then we'll watch this. It should drop down a little bit once those guys are charged up. So step one on a Victron system is always going to be to bring the firmware up to date on the inverters.
Right.
That's first step. They need to be to the newest firmware. Apps updated. I hate updates.
So while you're waiting for that, dumb question.
Yeah.
So I watched you charge. I thought you had to charge the caps before you connected the batteries, but you actually already connected the batteries.
I did charge the caps. When I hooked the power supply up, DC
Right,
went whoop.
Right, I saw that, but I didn't see you connect the batteries up. Oh. Duh.
Yeah.
Or in the parlance of my generation, don't.
Yeah, exactly. Yeah, that was definitely a dope.
I didn't even think about that you could do that. So that means you're able to connect that. That's the disconnect.
Yeah, these
so then
are
it
your
would have only
these
sparked
are your battery disconnects now.
It would have only sparked
Inside the switch.
inside the switch, not like.
Yeah, it wouldn't have sparked at the battery.
See, that was the whole thing. The whole Victron training is, in order to prevent it from sparking at the battery, you need to pre-charge the.
That is correct if you don't use a switch.
But why is? Okay, see, that is the difference between me being a dumb engineer,
Right.
and taking classes meant for a technician who understands this stuff intuitively.
Right. But yeah, if you don't use the switch, then yeah, you want to pre-charge the caps.
Right.
Whether it's a resistor or you pre-charge them the same way I just did.
Right.
Either way works. A
And then you
resistor just slowly charges them because it's only going to allow so much to go through in the current. But if you can pre-charge it with a power supply, I like hooking up a lab power supply first.
Right.
The reason being is the lab power supply has short circuit protection.
Right.
And if we see a short on the power supply, it's going to be seen as the current of the power supply will spike to whatever the power supply can output, which is 10 amps, which is fairly safe for it to spike. Versus the battery, if it has a short and you connect it, now it's going to discharge 200 amps or so at 24 volts, which is a big spark versus a little spark.
Right.
So I'd like to keep it as a little spark.
So why do I update my MPPTs all the time but leave the inverters the same?
Okay. So Victron's engineers are constantly working to better their product. by doing so, they're constantly, an MPPT tracking algorithm is constantly evolving.
Okay.
You know? And to get that maximum power point to track slightly faster or change the characteristics of the MPPT just slightly, that's what they're getting. By updating the firmware, they may be able to get you 0.1% more efficient out of the tracking algorithm.
Got it.
That 0.1% is absolutely worth updating the firmware for that 0.1%.
Right.
So that's what their engineers are constantly changing.
Okay.
But nothing's getting better in the inverters. So that's why we don't update these. But these products are always getting better in time.
Cool.
So that's
Thank
why.
you.
Yep. Phase WYE.
Okay.
Is what it is. But we're not doing that. We're not talking about 3-phase. So we're doing dual phase, 180 degrees.
Mm-hmm.
That's the American power grid. But the real trick to Victron inverters is this right here. The options for L2 phase. So we want an L2 that is floating with a return to its original phase. What this allows leg 2 to do is shift its phase angle between 180 degrees and 120 degrees.
Okay.
And why that's important. There's a lot of RV parks in America and throughout the world, and places that are just large in general, are typically going to have a true 3-phase service coming into the park. A true 3-phase service has 120 degrees between each phase. 120 degrees between each phase would mathematically work out to 122.08.
Mm-hmm.
Which is fine for most applications because most RVs don't need 240 volt circuits.
Right. Circuit 1 and Circuit 2 are independent of each other in most RVs.
Correct. So then if you have two 120 volt circuits, well, you can still power the entire RV on a 122.08 service. Now, if I had just 180 degrees out of phase turned on this, when you plug into a 122.08, the only thing that's going to happen is this inverter is going to start charging, but that inverter is going to stay as an inverter. And that's the situation we don't want to get into. So by selecting L2 floating with return to original phase, this inverter can actually shift its phase angle to 120 degrees to accept 122.08 power. And then whenever you're disconnected and you go to a park with 122.40, it'll shift back to 180 degrees out of phase. And that's some Victron special sauce that's built into their systems. All right, so I typically disable the UPS function when we're using an Onan generator that is not an inverter generator. An inverter generator gives us a very pure sine wave and good voltage regulation, but a lot of other generators do not give us good voltage regulation or even an accurate sine wave.
Right.
That is the UPS function. If I want the charger to activate on an Onan generator, I would disable that because the UPS function is trying to closely match the inverter sine wave with what's coming in.
Right.
Okay?
And you don't want it bouncing all over the place.
And if I'm trying to match the sine wave with a really crappy generator that's the sine waves all over the place,
It
the
won't
inverters
sync.
are going to be all over the place and they would never mesh. But when you have a good generator, like what this has in it, that's a inverter-based generator, we will enable the UPS function because your generator should be able to provide us with a good 120 volt output at a steady 60 hertz because it's an inverter-based generator.
Okay.
So we will have that enabled, and now your transfer switch will operate in 10 milliseconds.
Got it.
Because of the UPS function. If I disabled that, it would take like 20 or 30 for it to switch over, which is still as fast as the blink of an eye, but it's not UPS quality.
Well, and the difference is that my computer might see it and shut off.
Correct. All right, so the next thing, on mobile systems, we want a ground relay enabled.
Right.
So typically that would be on an off-grid system or different systems. That would be the authority having jurisdiction would tell us when and how he wants the ground relay. And they can make the choice. I only want the neutral ground bond to be done at the main panel. I don't want your inverters to do it. If the authority having jurisdiction says that, it's as simple for us as just disable that function. And now we've got control of it at the panel. But in a mobile application, it's important to have that neutral and ground bond.
Right.
Even when you are in inverter mode. Because if we have a fault somewhere in this vehicle and there is a short going to earth on the AC side, for whatever reason, it has to follow the effective fault current path, and we need it to have both paths, okay?
Right.
So it's going to have the neutral path, but if that path is broken, then it can take the ground path, and it can dissipate through the frame of the vehicle and provide a path of least resistance to prevent electric shock to a human. And that's the purpose of this, and that's why all these are connected and connected down to the frame of the vehicle. But some people will tell you that, oh, well, that's not a true neutral and ground bond, but it actually is. Even if you're isolated on rubber tires, it's still better than it not being there. Because if it's not there, you can become part of the circuit when you probably don't want to be.
You don't ever want to be the fuse.
Yeah, you don't want to be there. So, all right, now we're going to set the input shutdown. So typically lithium, we want to shut down the battery at 24 volts. So that's going to be our hard shutdown voltage. Now we can push that a little bit farther, and let's say we can go to 23, because 11.5 is usually a good shutdown voltage on a 12 volt system.
Okay.
So on this, we'll say 23. Okay. Now, the restart voltage, I will typically restart a system, let's say 12.8 if it was a 12 volt system.
Right.
So yeah, this should be fine.
13.4, right? Or
Do what?
12.8 times 2.
12.8 times 2.
120, 256, 25.6.
There you go. 25.6. That will be that voltage. Now we want to do the pre-alarm. The pre-alarm is when these inverters come on and they tell you, hey, our batteries are about to shut down. We're going to do that at 24.
Got it.
So at 24 volts, that's when these inverters will start blinking this light and telling you low battery.
Got it.
You also get a warning on your touch screen saying, hey, your battery's low. You are very close to shutdown at that point. We
Okay.
don't want to get there, but we also want the inverters to shut down before the batteries shut down and the BMS shuts down.
Right.
That voltage is typically at 10.5, which would translate to
21
volts on a 24 volt system. So that's how that works. We want this system to shut off before
The
that
batteries
shuts off.
does. Right.
All right, next step, we take it out of storage mode and we enable lithium batteries. We open the battery dialog, we select lithium iron phosphate and hit OK. Now, the absorption voltage is at 28.4.
Mm-hmm.
It's a little high for me. I like 28 to start. And the reason I like this is I like to slowly bring the batteries up to balance the cells.
Okay.
Because we can't assume that this battery cells are balanced from the factory.
Right.
But what we don't want to do is we don't want to create spikes within those cells. So we slowly charge them for, let's say, a week or so and play around with it. And then we start bringing these voltages up a little higher to get all the capacity out of it. I've got each inverter set to a charge current of 90 amps. Absorption time of 1 hour, which is sufficient for lithium iron phosphate batteries. We do not enable weak AC input unless there's a problem with the AC input. The charger is enabled, and I've got the charge current limited to 90 amps per inverter. Each inverter has a 120 amp 24 volt charger, but we're not going to push it that far. Once that's done, we hit send settings, we hit all devices and all settings. Now it's going to send all this data to both inverters. And then they'll kick off and kick back on. And we're good.
Boy, that hum's going to take a while to get used to.
You'll never hear it inside. If your head is in here, yeah, probably. But I
Well, the
think
bed's right over this.
you won't hear it. It's one of those, yeah, I mean, it's a transformer hum. If you had high frequency inverters, you could probably not hear that because you don't have the transformer, but yeah, it's just the nature of big copper transformers. All right, so the inverters are programmed. So now, fun part, we can turn this on. And if we, actually, let's bring the DC online.
Okay.
So you bring the DC into the DC and DC chargers. And this will start enabling all the 12-volt systems to function. And the output of these will come on. We got to ground this. He forgot to do that. No big deal. So the battery protects not allowing power to pass through currently until we get that ground.
Okay. We ran into a scheduling problem where we needed to move on to get to some medical stuff, and we had some bad weather in town with many inches of snow. So Chris and the team put a lot of extra hours in it late at night and in the cold to move the rig on to being complete. And everything's working great, but we didn't capture the last part of that process on video. So here's the completed panel. You can see that we have grid with 2 lines coming in, separately controlled. So one air conditioner is on, and then some lights. It's 4 o'clock in the afternoon, so we don't have any solar coming in right now, and we're in some trees. The alternator is the 7-pin connector off of the back of the F450. That's connected directly, and I get about 1.4 kilowatts off of that. You see that we've got the batteries fully charged because we're hooked up, and then of course we've got DC loads, and the front air conditioner just kicked on. Turns out that we're actually getting, I can run the front and the middle air conditioner in steady state a little over 2 kilowatts, which I think is pretty good. So here's the other view of that. Really cool, really nice to have. You see that I've got an also liquid propane gas marker here. So if I come to here and I go to levels, I've got inside temperature, and then my battery bay is 88 degrees, and inside temperature is set to 77, or is 77. And then I also have the propane tanks. So one tank's at 33%, one's at 43. We're just using that for cooking and water heating right now. So this is the Firefly display on the other wall. You can see that it doesn't really change, other than the fact that if you come into electrical, it looks like all of a sudden we have a bunch of errors on things because it's no longer connected to the electrical system. Pretty much everything we're doing is running through the Victron. So this display isn't really operational now. So I hope you enjoyed these 3 videos. This concludes our Powering Addy series. We will have one extra video here coming in the future when we go to put the extra solar panels on the roof. That hasn't quite happened yet due to weather, and so we'll update this to show that process here in a couple of weeks, and we're looking forward to that. But in the meantime, the system's working great. Boondocking is very easy. You don't even have to think about it, and boy is it nice when I go to set up or take down at the end of the day, or when we go to travel, then I can just pull the power cord outside when I'm ready to roll it up. I don't have to coordinate with what's going on inside. Likewise, when we pull in, the air conditioners are running, they're already set up, so I can set things up in a more orderly fashion without having to rush through to make sure that I get the air conditioning on, because we need to get it cool for the dogs. So it's just having the battery power and being able to have the rig comfortable up until the very last second, or as soon as we get in, really makes travel days a lot easier. So thanks for watching.
I've been so many places, I've seen them all with open eyes. Seen islands, open spaces, Serengeti sun slowly rise. All these memories, I hold them near me when I sail the Aegean Sea. But there's one place for me